go ahead and get started. First, I'd like to go over the exam today. I'm going to be kind of quick about it though. So if I skip over something that you want me to go over or you want me to slow down, just let me know. Okay, so number one, just identify the number. It gives us the square root of 1, which the square root of 1 is 1. So 1 is a natural number, it's a whole number, it's an integer, it's rational, it is not irrational, and it is a real number, it's not undefined. So it's everything but those two. Any questions? Alright. Second one. Identify the following number again. So this one gives us 10 over 0. Well, 10 divided by 0, anything divided by 0 really is undefined. And so that's the only thing that it can be, is undefined. Any questions? Alright. Next one, some actual algebra going on. It says, evaluate the following expression for the given values of the variables. Leave your answer in terms of pi, or use 3.14. Well, I'm going to leave it in terms of pi. So we just need to plug in our values for x and y. So x is, let's see, 3, y is negative 3. So we've got negative 9 times x, which is 3, squared, minus pi, y, which is negative 3, minus y cubed, so that's going to be negative 3 cubed. Now it's just a matter of order of operations. So let's see, I've got some exponents that I can take care of. 3 squared is going to be 9. So now I've got negative 9 times 9. This could be cleaned up a little bit. That should really be plus 3 pi. So go ahead and clean it up. But the other exponent is negative 3 cubed. Negative 3 times negative 3 times negative 3. That'll be negative 27, and then the extra negative here makes it positive. Then I've got negative 9 times 9, so negative 81. Then plus 3 pi. Plus 27, and just combine like terms now. So let's see, it's going to be negative 54 plus 3 pi. Any questions? None?
You also do it 3 pi minus 57?
Sure, yeah. Any other questions? Okay. Which actually I did have some people give me 3 pi minus 57, minus 54. That's fine.
Yeah.
Just as long as they had the correct signs on them. Same thing here, just plug in, see what we get. So x is 4, y is negative 2, then z is negative 1. So we've got some grouping symbols here. We've got, of course, the parentheses on this side, and then we've got the absolute value over here. So both of those count as grouping symbols. I'm going to start with the absolute value. So we've got inside here 4 plus negative 2. Really, that's like 4 minus 2. So 4 minus 2 is 2, and the absolute value of that is 2. Plus, let's see, 9 times negative 1 is 9. Or I'm sorry, negative 9. The negative 9 minus another 3 is negative 12. So 2 plus negative 12, or 2 minus 12, is negative 10. Any questions? Nope. Okay. Next, identify the property that justifies the following statement. This one was bonus. If you got it right, you got plus 5 points. I didn't mark it as a bonus because I wanted you to try it. Okay, so what we've got here in the statement is negative 7x minus 8 is the same thing as negative 8 minus 7x. So essentially all we've done is we've taken these two terms and flipped their order. Okay? So since we have moved the position of the terms, that is a commutative property of something. Now we've got to decide whether it's commutative property of addition or commutative property of multiplication. Well, I don't see any multiplication going on, but I do see some subtracting, which is the same thing as addition. It's really combination. So this is the commutative property of addition, which in fact is the reason why we can say that negative 54 plus 3 pi is the same thing as 3 pi minus 54. It's the commutative property. Any questions? Okay. Evaluate the following. It's just simplifying. See what you get. So I can do the negative 2 to the third, and that negative is in parentheses, so it will be included when I take that third power. So that's negative 2 times negative 2 times negative 2. So that's going to give me, let's see, negative 8. Bring down the rest of my expression. Okay. Now I see that I've got multiply and divide that I can do. So I'm going to multiply 8 times 8. It gives me 64. Divide by 9, so just put it over 9. And that'll be negative 8 plus 64 over 9 minus 8. Alright, well, let's combine any like terms that we have. The negative 8s are definitely like terms, so that's going to give me negative 16. I'm going to go ahead and put it over 1 since I know I'm going to have to deal with a fraction pretty soon. And now in order to combine these two fractions, they need to have common denominators to make them like terms. So I'm going to need to make this 1 into a 9, multiply it by 9. But I've got to do the same thing to the top. So negative 16 is also getting multiplied by 9. So that's going to give me, let's see, negative 144. So 4 plus 64, or 64 minus 144, whichever way you want to think about it, is going to be negative 80 over 9. Any questions? Nope. All right. Next. Again, simplify. So I see that I have an exponent here, so I should take that exponent. So z to the 0 power, anything to the 0 power, even if it's a variable, is 1. So really, this is negative 6 times 1, or just negative 6. Any questions on that one? Nah, I didn't think so. Okay. Really happy to see how well we did on these power properties. So the next one here is negative 2 in parentheses to the fourth. So that negative is being included in this. That means we have negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4. Go ahead and write this out real quick. Again, negative 2 times negative 2 is positive 4. Same thing for this is 4 times 4, 16. Any questions? Okay. Next. This one is negative 3 to the 6th, but that negative is not in parentheses with its number. So we will not include that negative when we take the power. So this is 3 times 3 times 3 times 3 times 3 times 3. Well, 3 times 3 is 9. So all of these pairs of 3's are going to give us 9's. And then 9 times 9 is 81. So really we need to figure out 81 times 9. And that should be, what is it? 720. I knew it was 720 something. Thank you. Negative 729. Again, the negative comes from it just drops down because it wasn't included in that power. Okay, next. Kind of hard to see because it's so small, but that is 1 over 4z to the negative 4th. So it's always nice to have positive exponents instead of negatives. So this negative exponent tells us to flip z, only z. I did have a few people mess up and flip the 4 as well. So that's going to flip up to the top, giving us z to the 4th over 4, and that's all we can do. Any questions on that one? Okay. Next, simplify the following expression. We've got 2 to the 2nd times 2 to the 3rd. Of course, we're multiplying these, which means we're going to add their exponents. So we get 2 to the 5th. Okay, so we know what 2 to the 4th is. It's 16. So this is 16 times another 2, which is, anybody know? 32, good. It's those binary or computer numbers. Really just powers of 2. Okay. So next, we've got basically the same thing, just n's instead of 2's. So 2 plus 8, it's going to give us n to the 10th. Okay. Next page. Got another one of these things with negative exponents in it, and yeah, I don't really want to deal with negative exponents, so I'm going to flip them to make them positive. So now I've got y to the 5th over y to the 9th. And since I'm dividing, that means that I'm going to be subtracting these exponents. So let's see, the difference of 5 and 9 is 4. The bigger one's on bottom. So I'm going to get 1 over y to the 4th. Any questions? Okay, just a few more. Again, this one's got negative exponents. I don't want to deal with them, so I'm going to just flip them. So we've got z to the 2nd times z to the negative 4th over z to the negative 9th. Flip the negative 4th and the negative 9th. We've got now z to the 2nd times z to the 9th all over z to the 4th. Let's see, z to the 2nd and z to the 9th is going to give me z to the 11th. And then 11 minus 4 is 7. Z to the 7th. Excuse me. Last one here, we've got x to the negative 3rd to the negative 2nd, which means that this is a power raised to a power, and we're going to multiply those powers. So negative 3 times negative 2 is x to the 6th. And one more, that's the bonus. What is 0 to the 0 power? Who's got it for me? It is. Because 0 to any power should be 0, but anything to the 0 power should be 1. So which one is it? Algebra at this point says, I don't know. It's undefined. Excellent. And again, that one was bonus 5 points. So in total, there was a opportunity for 10 bonus points. A lot of people actually got all 10. Okay. So last time we were talking about radicals. So radicals, remember, is another word for roots. So if I have something like square root of 16, this is a radical. And this is a perfect root, which means that when we take the root of this number, it gives us an integer out. So what integer does it give us? 4. However, most numbers are not perfect roots. In fact, the majority of our real numbers are imperfect. Square root of 72. So there's nothing that we can really say is an integer times in itself is 72. So this is going to give us an irrational number. If we plug it into the calculator, it's going to give us a number that has a decimal that just keeps going on and on and on and on and on without ever repeating. So what we can do instead of trying to find a value for this is try to simplify it. Try to find perfect roots inside of its factors. So what two numbers can I multiply together to get 72? 3 and which one?
21.
Okay. Of course, you could have also used something like 6 and 12 or any of the other factors. So what about 24?
2 and 12.
Okay. 12?
52.
And lastly, 6.
23.
Good. So once more, our goal with these things is to find pairs. Because what we're saying with the prime factors is that 72 is 2 times 2 times 2 times 3 times 3. Well, since we're multiplying all these things together, if we have something like 2 times 2, that's a square. That means that we have a perfect root. That number gets to come out. Same thing with the 3's. We've got 3 times 3 here. That's a perfect square. That gets to come out. However, not everything gets to come out. What is left over underneath that root? 2. It doesn't have anything left to pair up with, so it's got to stay underneath that root. Meaning that when we take all this together, of course 2 times 3 is 6, so we get 6 square roots of 2. Any questions? Okay. We also said that this becomes useful when we are adding or subtracting radicals. So something like the square root of 20 plus the square root of 45. The problem here is that they're not like terms. In order for them to be like terms, they need to have the same number underneath the same type of root. Well, if we simplify them, maybe we can find a common type of root. So 20 is what two numbers? 2 and 10. 10? Okay, so using these factors, give me the simplified form. 2 squared is 5. Good. And then 45 is what numbers? 5 and 9. Yeah, this is pretty simple. 9, of course, is 3 and 3 because it's a perfect square. So what's the simplified form here? 3 square roots of 5. Good. So now we have 2 square roots of 5 plus 3 square roots of 5. We have like terms. So how many square roots of 5 do we have altogether? 5 of them. Because of course 2 plus 3 is 5. Excellent. So this is where we left off yesterday. Are there any questions that we would like to ask? Nope, it's all still good? Okay. So I think I left off with this. Square root of 6 times square root of 2, right? And I said, yeah, we don't need like terms for multiplying. Doesn't matter what kind of number we're using. We can multiply anything by anything. So here we could multiply 6 times 2 and get 12, but I shouldn't really. It says because 6 times 2 is 12, and well, the factors of 12 are 6 and 2. So if I want to simplify 12, I'm kind of just making more work for myself. So it's pretty much always a good idea to factor these numbers instead. Because remember, when we're multiplying, since what factoring does is say, all right, this times this is this, well, we can say that the whole thing as a expression is this times this times this times this would get us the entire thing. So we can make matches across the trees, get that pair of 2's there. and 1 doesn't really matter. So we can take a 2 out and have a 3 left over, and we know that 6 times, or square root of 6 times square root of 2 is 2 square root of 3. Okay, how about square root of 12 times the square root of 3? If you got a good eye, you might be able to tell me immediately what the answer is. But that does take some practice. So let's break up 12. 6 and 2. And of course 6. 3 and 2. Okay. Well, I got a pair of 2s, don't I? What else do I have a pair of? 3s. So a 2 comes out, a 3 comes out. What's left over? Well, we already broke it up as 2 and 3. Trick question, nothing. There's nothing left over. So our answer is just 6. Why? Well, if you think 2 times 3 is, 12 times 3 is, 36. 36 is a perfect square root. Okay, let's try this one then. Square root of 32 times square root of 50. Well, 32 times 50 has got to be a huge number, right? So let's not multiply them. Let's try to simplify and see what we get. What is 32? Okay, and 16? Oh, hey, we don't need to go any further with 4 and 4. It's already a pair, right? All right, so we'll go ahead and take that 4 out now. How about 50? Okay. About 10. All right. What pairs do I have? 5s and 2s. So I can take a 5 out, and then I can take a 2 out. Do I have anything left over? Nope. So 4 times 5 is 20. 20 times 2 is 40. So once again, apparently we had a perfect root. In fact, 1600. Well, 1600 is 16 with 2 zeros. 16 is perfect square of 4. And then those zeros just come out to be, well, 2 zeros is 100. The root of 100 is 10. Ah, there we go. But ultimately, I feel like this is the easier way to think about it. Any questions? None? Okay. What about this then? What if I have something like square root of 18 over the square root of 50? Well, there are a few ways that I can go about doing this, and I'll do 2 of them. Okay, so the first way is something that we would be familiar with, and that's simplifying these, right? So 18 is 2 times 9. 9 is a perfect square of 3, so this would be 3 square roots of 2. Okay, how about 50? 50 is 5 times 10. 10 is 5 times 2. So we've got a perfect square of 5s. Means we can take a 5 out and have 2 left over. Well, we've got 3 times the square root of 2 divided by 5 times the square root of 2. Those square roots of 2 can cancel, leaving us with just 3/5. Make sense? But the other way we could do it is we could say, well, if we can multiply roots together to get a single root, then we could probably do the same thing with dividing, since dividing is basically the same as multiplying, just opposite directions. So we can make this into a single root of 18 over 50 and just deal with the fraction instead. Well, 18 and 50, that can be simplified. In fact, they can both be divided by 2. Just like we did up here. So that gets us the square root of 9 over 25. And oh hey, 9 and 25 are both perfect roots, so we can take those roots. Square root of 9 is 3. Square root of 25 is 5. Either way you want to do that, fine by me. But I think these are the 2 easiest ways to think about them. Any questions? So I'm not really concerned with y'all being able to do this. This is stuff that we've been doing so far. There's skills that you should have. The one that I want to make sure I go over today, though, is something like this. 4 over the square root of 2. So remember that fractions have 2 parts to them. They have a numerator and a denominator. The numerator is the top number. The denominator is the bottom number. And the denominator is probably more important than the numerator, honestly. The best way, or at least the way I think about fractions, is as a circle, or like a pie or something. And you can divide this circle into parts. So like if I divide it in 2 parts, I've literally divided it by 2. Or in other words, I have 1/2, denominator 2. Right? Or I could divide it into 6ths. That's divided by 6, or denominator 6. That denominator is telling us how many, what kind of slice we have. So what kind of number. Excuse me?
Would it be a half? Or like, I was thinking about it, if you divide 4 by 2, then would it come up with 1?
We can't divide 4 by 2 because this is a perfectly fine number, sure, but 2, do we actually know the value of it? The square root of 2.
It's 2 and 1. But there's no seconds.
Well, it's not 2 and 1 because it's stuck underneath that root. Remember that we're still doing something to 2. So if we put this into a calculator, we get something like 1 point something, 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 something.
Mm-hmm.
So we don't actually know the value of it. We can't divide 4 by it.
Okay.
And that's the other problem with it, is that we don't know what kind of slice we have then. So mathematicians, when we come across something like this, we say, no, that's not a very good fraction. Because again, we don't know what kind of thing we're talking about. We have 4 of them, sure. The numerator tells us we have 4 of these things. But we don't know what kind of things we have. So what we need to do is somehow rationalize this denominator. In other words, make this into something that isn't a root. I mean, the 2 is fine. It's the root that's giving us problems. So how do we cancel out a square root? Not just another root.
Right, itself.
By itself, yeah. Remember that multiplying something by itself is squaring, and squaring is the opposite of a square root. So we can multiply this times itself, but we also need to multiply the top by that, since we want to make sure we keep our fraction really the same. We don't want to change the value of our fraction. So the square root of 2 times the square root of 2, that basically cancels out those square roots and gives us 2. And then 4 times the square root of 2 is 4 square roots of 2. Okay, is there anything else we can do to this though? Look carefully. Think about the top and bottom numbers.
You can't swap the 2,
Not the 2's.
or the 2 and 4.
Yes, we can divide the 4 into 2. So 4 divided by 2 gives us 2, so we have 2 square roots of 2 now. Just the same way that we did with these, since they were common between top and bottom. Really, 4 is 2 times 2, so we can cancel out a 2 from the 4. Any questions? Makes sense? Okay. Remember this method here of multiplying this by itself. This will come up many more times in the future. It may not look like it, but it will. Any questions? All right, then that'll do it for today. So nothing's happening over the weekend as far as this class is concerned. But speaking of the weekend, be careful on Sunday. There's going to be really bad weather on Sunday. Preferably stay inside. All right, but I hope you have a good weekend, and I will see y'all on Monday. You too. Thank you.